Thank you very much, Adriana. My name is Andrea Cipa. I am a site planner and flood expert working for SDC, Swiss Humanitarian Aid, seconded to UNHCR. And today I'm going to present you a workflow together with Nadine Antenin from the start to the end, how to develop a flood hazard map. It's not an academic approach, it's an approach that is possible to do it everywhere, especially in developing country where we have not so much material, not so much information. It's going to be an hazard map related to flooding at local scale in order to be clear that we are not presenting a flooding hazard map at global scale on huge surfaces, but localized, especially in settlement, in villages. During this workflow, we are going to identify at the beginning all the infrastructure that are at risk and what type of infrastructure. I'm going to show how. We are going to present a plugin in qGIS developed by ETH Zurich, the Technical School of Zurich, together with the GTH, the Geneva Technical Hub. And also we are going to see how to use the compendium of mitigation measure, which is a manual that collect most of the mitigation measure related to flooding. And we are going to have an insight on the local data collection guide through Nadine. During this presentation, it's impossible to go deep in each step. That's why I'm going to give you in the chat the link where you can find the topics where I'm discussing. Nadine is going to present part of it. When it is her turn, she is going to present herself as well. It's going to be an overview, not deep in the detail. This workflow is divided in 5 main big steps. Each step, of course, has several sub-steps. It is divided in a first part, a desk study, a study that you can do at home. It doesn't matter if you are in Norwegian, in South Africa, or in Switzerland. Based on that, with this result, you go on the field, you make a field survey, and based on the field survey together, merge with the desk study, you define the work at the mitigation measure and you implement the work. This is a workflow that is in constant development because the techniques improves a lot. And so you cannot say, okay, it's finished like that forever. It is always have to be revised. The only limitation of this workflow is that you need to have a basic knowledge on qGIS software. Without this basic knowledge, it is very difficult to follow the workflow. On the other hand, to gain this knowledge on qGIS is not that difficult. There's plenty of tutorials online, and also I'm developing a basic guide for site planner that is going to be published very soon. We decided to use qGIS because qGIS is an open source software. Means available for everyone, everywhere in the world, in many languages, so no need for licenses and to spend money on that. So the first step of the 5, it's a very important step, is the analysis of the situation. Here you see listed the points that we are going to discuss point by point. The result of this first step is to have a detailed base map, base of information that you can find online. First step, it might sound stupid, but you have to georeference your location. My experience, when you go on the field and you want to visit the location of interest, people give you a map, maybe done by AutoCAD, and this map is even not georeferenced. So you don't know exactly what is behind the point, the area of interest, the village close by. We are going to go through this workflow through a location in the Republic of Congo, Betu. You see here the situation. Betu is a village close to a river, and east of Betu we have a refugee site. So for us as UNHCR, the refugee site is the center of interest, but of course we cannot only concentrate on the refugee site and forget totally about the village. Mitigation measure in flooding situation involves all the surrounding. That's why the first step is really to georeference your location, identify the boundary of your location and the village close by that are somehow influenced by your intervention. Next point would be identification of all the facilities in the area. And this you can do it mainly based on OpenStreetMap. OpenStreetMap gives you the opportunity to download in vector format all the facility, that means shelters, roads, type of land. In the chat, I will give you now the link where you can find all this information based on OpenStreetMap. It's important when you download this information that you check all those possibilities and you find the best one, actually, the most recent one, the most accurate one, because this depends a lot on your location. You see, I have here 6 contacts, but you have many more probably. So you check a little bit everywhere and you find the best one. In the attribute, you might even have more information. For example, this is a church, this is an industrial area, this is a school. So it's important also to identify what type of infrastructure and what type of soil you have, what type of cover. And how to do that is very easy, and on each site is a different way. Sometimes you have to extract just the area of interest. Sometimes you can extract all the country. It depends a little bit on the web page that you are using. And a very important point is to identify your projection. Why? Normally when you download from the internet information like OpenStreetMap, this information is all in a geographic projection, which is fine as long as you want to show a map. But it is not good if you need to make any type of map analysis, especially terrain analysis. That's why you should, as much as possible, convert all your information in metric projection, UTM projection. And for that also, it's rather easy. There is a plugin in qGIS, which is called lat-long tool. And through this plugin, you find the right projection, metric projection of your location. From now on, you should set your qGIS software in metric projection, standard UTM, in that case for B2, 34 North. This is important because many of our colleagues in the field, they are working with CAD software, Vectorworks, AutoCAD, whatever. And if you do not develop your workflow in a metric projection, it will be impossible to export it later on in AutoCAD. And on the other side, it's also impossible or not easy to import an AutoCAD drawing into GIS software if it is not in metric projection, if it is not in UTM projection. Next step would be to download no more vector layers, but raster images. And again, here, the GIS software is the best tool for that. Through dedicated plugin, for example, Quick Map Service, or through the XYZ tiles, you can download a big number of raster images. Here in the screen, you can see, for example, Google Satellite, Bing Satellite, Yandex Satellite, which are 3 images of the area with a different resolution. But then you have plenty of other maps, like Google Terrain, Esri Topo, OPRV Carte, Stamen Positron, plenty of possibility. The disadvantage of these, let's say, raster images is that we do not know when the image has been taken. So maybe the image is old, maybe it's new, we don't know, but fine. At least we have information, and more image, different image we have, more information we can have. The other disadvantage of this way is that you need a constant internet connection, which is fine nowadays in most of the office, but not always. If you are in a remote area where internet is weak, or if you rely on your mobile phone internet, this downloading of a raster image complicated. Therefore, I also like to mention this SAS Planet, which is an open source software, a Russian software, which gives you the possibility to download the images in different scale, and then you have it on your computer forever, so you don't need to connect always on internet. So now we have our site georeference, we have all the facilities, road and shelters in vector format. We have as well raster images, as many as we can. And now it's time to go to a very important step, to identify the digital terrain model. In internet, you might find many digital terrain model, but I advise you to use the FABDEM digital terrain model. FABDEM digital terrain model is a digital terrain model that removes forest and buildings. So it removes trees, it removes houses and shelters. And this is, for the developing country, the most accurate one. Recently, I did a study. I have analyzed more than 10,000 points with elevation taken by total station, and I have compared them with the digital terrain models that are free available, so SRTM and AsterGDM and many others. And the result was pretty much amazing, because I've realized that the FABDEM, even if it's not perfect, is not that bad, especially in flat area where you do not have vegetation. The disadvantage of FABDEM is that you need to find the right tile, and each tile is around 2 gigabytes. And of course, if you don't have a good internet connection and if you rely on your mobile phone, it is complicated. But usually you can do it in the office, and you do it once for your country, and then you have it, let's say, forever, or at least for the next year. Of course, from time to time you have to update it, because those pages are updated frequently. Now, what can you do with the digital terrain model? First, what you can do is to develop contour line. Okay, the digital terrain model that you are going to download, the FABDEM, has a resolution of 30 meters per pixel. It is not a good resolution, so each elevation is 900 square meter. But on the other hand, between tiles, between the pixel, it is an approximation. So if the terrain is flat, if there is no big, let's say, stones or whatever, the result is pretty much good. Of course, with the FABDEM, you cannot identify a drainage. You cannot identify a wall. This for sure not. But on the other hand, you can develop contour line at any interval that you like, even every 5 centimeters if you want. If it makes sense is another question, but at least now, having the contour line, you can understand if your terrain is flat or steep. Remember that if the terrain is flat, it is more prone to flood. If the terrain is steep, water runs. Now we have our base map. We have all the information of the map. We have the location georeferenced. We have the facilities, road, shelter. We have the contour line. We know if it's steep or not steep. And we have our base map. That is the basis of our next step, which is step 2, the creation of the local flood hazard map and the vulnerability map. Still, do not forget that you are still at home. You never went out of your office, so you have no idea of the reality. It's everything taken from the internet. So if you are in Geneva and you have to do something in Sudan, okay, you can ask your colleagues, fine, but before asking your colleagues, there is 2 pages that you need absolutely to visit. First one is called the Think Hazard page. You enter the location, Beto, in Congo, okay, and then you see what type of problem we have in Beto in Congo. So we see we have river flood, interesting. We have urban flood, interesting, and wildfire. Okay, this is actually what we want to know. It doesn't help me really too much. So let's click on the river flood, and we see here, okay, there is some explanation, what type of flooding we have, but important is that here we have some first contact. We have this web page, we can have a look. Maybe I get some interesting information, maybe not, even an email. Maybe it's interesting, maybe not. African Regional Climate Center, I have no idea what it is, but I can contact them, ask him. So get the first, let's say, feeling of the situation in this area of interest. The second page is the Global Flood Database. The Global Flood Database, you check your village, your area of interest, Congo in that case, it's Congo. And then you see the biggest heavy rain of the history. This is very important to remember this date, because these are the biggest event. So now, for example, if I take the event of the 27th of January 2005, I see that it is not in my region. It is this event. So it's not in B2, so I'm not interested. But you can check until you get the event of your region, which is this one in that case. And you can see you can see at the beginning what happens at that day, huge event. Okay. B2, I zoom in. Okay, there was a classical river flooding. Here I have my map, but you can see the resolution is very bad. Fine, you can download the map, you can use it as a first feeling. With this resolution, you cannot really start too much, but at least you know that, okay, we have a river flooding here. B2 village is in danger, or it can be touched by the river flooding. Our site, which is here, apparently not. But fine, I have the dates, and these are going to be interesting for me when I go to the remote sensing. So I remember those dates. And then, of course, meanwhile, still from home, still from Geneva, you can contact your colleagues on the field, can contact eventually authority, NGOs. I mean, you can start to gather information with many channels that you can find online. But let's continue to the next step of the step number 2, which would be the identification of the watersheds. The watershed is actually a way to represent how water flows when it rains. You can see the map is not very good. Here we have our site, the red dots, and here we have our Bento village. If it rains, we will have natural drained water. Part of the water will evaporate, part of the water will percolate into the terrain, but part of the water, if it rains a lot, will goes downwards. And this is the natural drain that is going to be created during a heavy rainy day. What does it mean? This means that here around those blue line, definitely there will be water. And if there is a flooding caused by the rain, so a rain flooding, this will be around those, let's say, streams, if the digital terrain model is correct. And we have also the watershed. What does it mean? If we take, for example, this small drain here, all the water that falls into this green area will somehow alimент this river. So if I want to decrease the amount of water of these small streams, I have to retain the water in this catchment. So I can plant tree, I can make infiltration galleries. There are many technical solutions to decrease the water amount. If I decrease the amount of water of these streams, I will have less erosion if the water has a certain speed, but also I will have less flooding due to this rain event. We have created now the watershed analysis. Now, on the same, let's say, terrain analysis level, we want to understand where you have depression or so-called sinks. Why? Because when it rains, the water, like I told you, infiltrate partially, evaporate partially. But if we have a sink, the water will stay, and maybe only 10 centimeter, maybe only 5 centimeter, but it is going to be considered as a flooding. It is going to be considered as an area where you cannot build. And through the contour line, or through dedicated logarithm in GIS software, you can identify the depression or the sink. You can do it visually. If you look at this map, you see here we have polygons. Those polygons, they can be either hills or depression. If there are hills, of course, the elevation increase. If there are depression, the elevation decrease. And you can identify, okay, this is a sink, it means water goes down here and goes up here. So it means when it rains, most probably this area is going to be flooded. And now we will link already two steps together. The first step, we did the watershed analysis, and we have identified the natural stream. Now we have identified a depression or a sink. So what does it mean? It means that maybe I can make a drainage that goes this way up to the river, so that I avoid having stagnant water here, maybe. And all depends, of course, of the quality of your digital terrain model. But since I'm in Geneva or in Switzerland, I have no idea if what I'm doing, it makes sense or not. Now another analysis. I have the river. I have seen through the hazard map to the global flood database that the biggest and most dangerous flooding is coming from the river. Interesting, but I have no idea how much water has this river. But what I know what is the river, and through specific, let's say, GIS management, I can give to this river the elevation. I link the river location to the elevation through the digital terrain model, and I have the elevation of my river. Now what I do, I increase the water of the river of 1 meter, of 2 meters, 3 meters, 4 meters, and what I see the low land along the riverbed. I know that if I increase of 5 meters the water of this river in Bentiu, this is the area which is going to be flooded first. And this one. Here I have no people, but here I have people. I have already a feeling of the most, let's say, area of danger along the river. And then later on, when we are on the field, asking the people the level of the river, they will tell me, the water came to this point here. And then I just have to increase the water up to the point where people say that the water is arriving. And then I can really kind of shape, let's say, the most probable flood-prone area along the riverbed. So we have defined the low areas along the river. It means the area that are flood-prone along the river. We have another type of flood. Flooding due to groundwater. If your groundwater level is very high, then it is also possible that the water is coming from the soil. I give you now a link for this site. This is a UNHCR site that has most of the boreholes. Now, if you zoom to Bentiu, you see those boreholes. We have in the village some boreholes, and we have in the site some boreholes. I click on any boreholes, and I see the static water level. Here I see I have 7.22 meter static water level. Here I have 7.2. It's not that high, but it's also not very low. So a flooding due to groundwater is not excluded. Depends how big is the fluctuation during the rainy season. But of course, if I have static water level of 1 meter below the soil, the likelihood to have a flooding through groundwater is very high. If I have my static water level at 30 meters, maybe I cannot count on groundwater flooding. So this also helps you to understand if you should have a look, at least when you go on the field. You can ask the people what's about the groundwater. You can have a look at the latrines, if there are latrines, to see where is the groundwater, static water level, and other information which is very useful. So now I know the groundwater level, I know the river flood-prone area due to river flooding, I know the depression, and at this point I should have enough information to understand what type of flood I have in this area. We can have a river flood that we have seen, pluvial flood that we have for better, urban flood probably yes, because the terrain in the villages is very flat, groundwater flood not clear, 7 meter maybe yes, maybe no, coastal flood for sure not, flash flood for sure not, glacier we forget about that. Do not forget that I didn't go out of my office. I know all this only through analysis. And it's not finished. And now we go to remote sensing. Remote sensing might sound very complicated, but in reality it is not complicated, and especially for free. We have, for flooding, satellites which are delivering every day a lot of images. Those images are for free. And for flooding especially, we have Sentinel-1, Sentinel-2, Landsat 8, and to some extent also MODIS. And to access to these images, it's very easy. You have several possibilities. We have a dedicated GIS plugin. I will give you now the link to the tutorial with the GIS plugin. But you have the Copernicus browser, very user-friendly. Snap, a software, open source, dedicated for satellite. Google Earth Engine, little bit more complicated, but with the AI, it's easy to use. And you have UNOSAT and AirData and many others. First, the advantage of this remote sensing is that is free. You have a lot of images ranging from 10 years ago up to today. So the last image maybe is yesterday, and easy to access. And the disadvantage is that the resolution is not that good. You have 10 meter per pixel, so 100 square meter per pixel, but for flooding purpose is enough. The disadvantage is that maybe you need to spend some time on understanding. Just a satellite like Sentinel-2, for example, it has 14 cameras. Each camera has a different wavelength, and your task would be to take the right date and to combine those images in a way that the information that you are interested to, for example, flooding, appears. If you look, for example, at this image of water in wetland, you see the blue spot. The blue spot is the water. So if you have the right day during the flooding period, you might have identified the flooded area at that very day. But be careful, it's not so easy, and this is an advantage, to interpretate the images. You have many false positive. For example, here you have a cloud, and then you might have the shadow of the cloud. This is probably this here, probably is a false positive because they have a cloud. So the shadow might make false positive. So the interpretation is sometimes difficult, and not only that is the problem. The problem is that when you have flooding situation, it is mostly during rainy days, so it's cloudy. So you don't see anything, you just see cloud. Check the date of the most flooding. You can check the page that I've shown before. You can ask local people, and you go through, and step by step you find finally the good images where you can find the flood. Here you have Sentinel-2 short-wave infrared, for example. Darker can be either shelter or float. So again, you can see the natural stream that I did with the watershed analysis, and you can see darker can be sheltered, but it can also be floating. And here you have in Sentinel-2 again the moisture index. More blue intense is more wet, and wet doesn't need to be float, but for sure wet, maybe mud. It's also something that it can be interesting. So through that, really you can have more information of your area of interest. And then you have UNOSAT. UNOSAT, it's a little bit different than the satellite, because UNOSAT doesn't give you images, picture taken from the satellite, but it gives you already elaborated flooding hazard map, which is fine because you don't have to do it yourself. On the other hand, you do not have this flexibility to choose the date that you want, so you have to take what they give you. So like this is a flooding on one date, I don't remember which one. Fine, better than nothing, but also UNOSAT is a web page that you have to consult if you want to identify flooding through the remote sensing. So powerful tool, remote sensing, we can identify the flooding of the past on a resolution of 10 meter per pixel. Now we have so much information. Okay, I've spent maybe 2 days browsing internet, downloading images. I have my base map. I have my flooding, river flooding. I have my pluvial flooding, groundwater flooding, depression, images from the satellite. Eventually, if possible, high resolution image given by UNOSAT because we requested or someone requested. If you are lucky, you can have even a drone images if there is a drone on the. So many layers. And like you know, the GIS software works on layer, and now it's matter to overlap all those layers and to develop your flood hazard map and vulnerability map. Again, I repeat for the 5th mile, this is pure theoretic. I didn't go out of my office, but I start to have a feeling what could happen. And this is, for example, the flood hazard map of Bentiu, Congo. True, not true, I don't know, but I will know it once I go on the field. But before going into the field, I have to put my map into my GPS or into my mobile phone, because the area is so big that I will be lost if I don't have my background map on my phone. There are tools. I like to use Avenza app. Avenza map, it's actually an application for mobile phone, Android, and the other one, and the Apple one. You have your map done by GIS, and you can upload in your phone your map, and this is like a GPS. You know exactly where you are. So it's just matter to go, for example, at the depression point, check, is it true that I have a depression? Is it true that there is a flooding hazard here? Maybe you can see that yourself, maybe not, you can ask, but we move now to the step number 3, which is the physical field assessment. I have developed my desk study. I have collected all the information I could collect, and now with those information I go in the field. I take my plane and I go to Congo. I'm there in the field office, and I have a localized approach. First, I need to speak with the local engineer, my colleagues that knows the situation very well. I will show my map, start to have really a more in-depth and real approach. I might have historical maps. I might ask for meteorological phenomena that I didn't know, maybe very localized. Especially what I have, which is impossible to find remote, is the human factor. I might have drainage. I might have a water supply system or a sewage system. I might have a very recent deforestation that are actually destroying all the environment. I might have a road network that it is not in the map, with the road with culvert, elevated roads, so that are doing like a dam. So that's why it's time with my local engineer who knows the situation to consult local authorities and the local expert, especially to ask for plans. Maybe there are plans. If they make a road, there might be a plan. If they do whatever they do, there might be a plan. Important it is that all information that I collect in the field is geo-referenced with my GPS. And of course, I need also to speak with the local people, because they are there, they know exactly how a flood in this area looks like, from where is coming the water, and all this information geo-referenced. I have to be confronted with my, let's say, hazard map done in the office. Let's see if it makes sense or not what I did. Maybe not. Without my hazard map done previously in the office, I will be kind of lost in the field, because I don't know where to do. I don't know where to go. I don't know what to ask. But now I have already an idea where to go and what to ask. So finally, the idea is to revise and update and finalize the facility map, also because many buildings that I was identifying with OpenStreetMap before, maybe they are not there anymore, or there are many more. So what type of buildings? It's important to know. It's a school, it's a hospital, maybe. And I update and finalize my flood hazard map based on the findings on the ground. Now, on the ground, how do I observe the ground? Of course, water often leaves visible traces in the path. So you can see drainage, which is impossible to identify through satellite images. You can see terraces, like in the picture you can see here. This is obviously a river erosion of the past. Water can come up to here. You can see this type of erosion. You have in the city drainage that are actually not visible in the satellite images. So this drainage need to be taken by your GPS and integrated into your flooding map, because you know the water is going through this way. You can see this type of kind of drainage, deforestation, which also probably increase the amount of water that you are expecting. Also, you have to have a look at the soil. Floods deposit specific type of silt, clay, or sand. So soil also gives you an idea if the area is flood prone or not. Vegetation also gives you an idea if the area is flood prone or not, or lack of vegetation. And there is another issue that you have to consider when you read the terrain. I have an example. You see the picture on the left. It was Bahrain, Pakistan, Swat Valley 2014. There was a huge riverbed and there was no flooding. And then 2022, when we went there with SDC, the situation was on the right. And then you ask yourself, how come there is so much water? It's exactly the same place 8 years after. What happens there? The situation is like that in 2014 you have a huge riverbed. 2022 there was an event. The riverbed was filled by debris during this event, and then 2023 the riverbed is much smaller. It means every time that it rains now you have this situation. So now the village is flood prone, but 10 years ago it was not flood prone. This is something that you have to take in consideration. You work with your digital terrain model, which was maybe taken 5 years ago, but it might not be real because of the changes of the nature, and especially along rivers. This change very frequently. After each event you might have a different riverbed, and this you need to consider and try to understand. Then something also very funny. Sometimes you have to see what is not there. The authority gives you a location and they tell that is a beautiful area to make a camp, a site. And you see it's a beautiful area, flat, fine, but there is nothing, and you ask why there is nothing. You might ask local population, why you don't build shelters? They might tell you because it's flood prone, then it's clear. But they might tell you, because it's not good. The issue is because even local population might have a hidden agenda. Maybe they want the UN to come and to build the site because they want the access, because they want the international community to be there. So they don't give a shit if the area is flood prone, but they would like to have a site because of the support that they are going to receive through the humanitarian aid. On another question, why the road is not passing through there? Why there is no trees there? So you have a look at what you do not see. Why there is no agricultural? Whatever information you collect, again, I repeat, georeference it. And of course, if I am a Muzungu, first of all, I will not be able to speak the language. You might have to ask your local colleague who speak the language, but even he might be taken because the hidden agendas sometimes are very difficult to find out. Here I have an example that I lived in 2014 in Gambella. When I came there, it was a flooding period, huge chaos, and you see the flight is totally flooded. But if you look at this picture carefully, and if you have listened to my words before, you can see something interesting. You see the road was there before and is elevated. The first question that a site planner should ask himself, why did they elevate a road? They don't elevate a road for fun. They elevate a road because there was flooding. So the site planner who did this site should have kind of understood that this area is not adequate for a refugee site, just because of the road. Reading what is not there, it's an exercise that is not so easy to do. With time and experience, probably you can do that. But now our colleagues, they have developed a system to speak with the local people and to collect information locally. It's a guide called Local Data Collection Guide. And now I would like to give the words to Nadine, who first should introduce herself, and then she can start with the presentation of this local data collection guide, which is available, of course, for free in internet.
Thank you, Andrea. Yes, I'm Nadine, and I work for the Zurich Technical University. And we had a project the last 3 years where we developed a toolbox also as a flood risk mitigation toolbox. And there is 3 elements in this toolbox, and I'm going to present them just shortly, and they are kind of part of this bigger workflow Andrea now presented. And one is the first one, this local data collection guide. As Andrea already said, it's important to talk to the people on the ground. And in this guide, you find recommendations and examples how to collect that information. There is, for example, the possibility to organize a participative mapping workshop, and you find methodology inside this guide where you would gather people on site, everyone that might know about past floods. Is it the residents of the settlement? Is it the residents of the host community? Is it the local authorities? Then you try to map the hazard, but also like the vulnerabilities on maps on paper together, and try to collect as much information as possible in this manner. And one tool I want to specially mention here we work with is SketchMap tool. You see the link on the slide here. It's a really simple online tool where you can, over OpenStreetMap, choose your area of interest. Let's say it's the Betu settlement. And then you print the maps in this raster where you see the picture, and there is a QR code and some points on the map. And then you map on these paper maps. You draw, like you see also in this picture, and then you can take a picture with the phone and upload this picture again in the same online tool, which is just a home page actually. And then it makes directly a shapefile, which is georeferenced of your site with the areas you marked, and you would say there was flooding, or this is an important site, or this is an important house, which is vulnerable. Generally, in this local data collection guide, you find also methodology for doing interviews, and yeah, these participatory mapping workshops. Then another instrument of the toolbox we developed together with UNHCR is the GIS tool or plugin actually, which is a small plugin which has 14 steps inside qGIS to create risk mitigation maps out of your hazard map, which Andrea now explained how you would create the hazard map. And out of the vulnerability mapping, you can, it does calculate actually the areas of that are especially on risk. And to explain that a bit easier, we can show the video now. That's the most easy.
This video is a step-by-step guide on how to use the GIS tool with local data. To start, you have to adjust the map view so that the focus is on the settlement you want to analyze. To do this, you can either zoom in on the location or enter the coordinates and scale in the status bar. In the first step, you have to draw the outline of the settlement. Left-click to set edge point and complete the drawing by right-clicking. In the second step, you have to upload transport infrastructure data, buildings data, and river and flood data. If there is pluvial flood data available, you can also upload it in this step. To upload transport infrastructure data, select the correct shapefile and wait until the layer appears on the map. To upload buildings data, choose the local data upload option and select the correct shapefile. To upload river and flood data, you also have to choose the local data upload option and select the correct shapefile. In this window, you need to edit the attribute table of the local river and flood data to make sure that all the required information is present. To start editing, click on the Edit button in the upper left corner. Enter grid code and repeat year values for each feature. In step 3, you can add or adjust areas prone to riverine floods. Make sure that the correct layer is selected in the Layers window. Then left-click to set edge point and complete the drawing by right-clicking. In step 4, you can do the same for pluvial floods, even if you have not uploaded pluvial flood data in step 2. By clicking on step 5, the hazard areas are automatically computed and displayed. In step 6, you are able to change building type and type of construction of an existing building. Make sure that the correct layer is selected in the Layers window. Then left-click to set edge point and complete the drawing by right-clicking. In step 7, you can add buildings that are missing from the data. You also have to assign building type and type of construction. In step 8, you could add technical infrastructure in the same way, and in step 9, you could add transport infrastructure. By clicking on step 10, the risk areas are calculated automatically. It is completed when the layers appear on the map. In step 11, you can adjust the risk levels manually. Choose the layer to be adjusted and the new risk level before outlining the area. By clicking on step 12, the risk maps are exported to your project folder. The exporting has been completed when the success message appears. In step 13, you can filter the risk mitigation measures according to your preferred characteristics in various categories by checking the corresponding boxes. By clicking on the last step, the risk maps, including a table with suitable risk mitigation measures, are exported to your project folder.
Plugin should facilitate to identify the mitigation strategies which are localized. And here just a few examples of mitigation measure. We see a shelter which is elevated. We see a road who's actually doing as a dam, so you need drainage. Every time that you develop a mitigation measure, you should reflect this mitigation measure in your GIS again, run again the workflow and see if the flood-prone area decrease or change, of course. This is the idea behind. So you redo the workflow, you redo the hazard mapping, and with the mitigation measure implemented, at least on the paper, and see if it really makes sense or not. And of course, the technical analysis is fine, you have to do it, but you have the human factor you have to consider. Everything needs to be consulted with the people, so the priorities need to be consulted with the people. Local authority and actors need to be consulted. The budget that you have available, of course, play a big role, and this in the filter section of the mitigation measures, you also can say I have a small budget, a big budget, and also the cultural background also of the area of interest need to be considered when you develop a mitigation measure. That's very clear. And now we go to the step 5. I don't want to spend too much time to the step 5 because this is more the financial and the implementation step. You have to run the cost benefit analysis. Once you have, let's say, your options of mitigation measure, you have to see what is my cost and what is my benefit. And of course, the cost need to be considered for the cost, the initial investments, the construction, the flood barrier, for example, the equipment, the warning system, depending on the mitigation measure that you are choosing, there are different costs. training and capacity building. Then you need to consider as a cost the project management and the administrative cost, of course. And then the indirect or opportunity cost. For example, if one of the measures is to displace the people or to displace the economic activities of the people, how much it would cost for the people to do the displacement. It is a temporary displacement or a permanent displacement. This is also kind of cost that should be considered. On that, I have to admit, I didn't make any type of tutorial. This is a chapter that needs to be developed further in depth by an economist, most probably, not by me. But then, of course, close to the cost, you need to observe the benefit. You do your mitigation. For example, what type of decrease of damage do we have if we do this mitigation measure? So we avoid to rebuild and to repair. What does it mean in terms of benefit? We do not lose life. What does it mean? Or injuries. We do not lose cattle. What does it mean? And then we have the reduction of indirect damages, like we do not stop the business because the marketplace is not flooded. So what does it mean in terms of income? We have the social environmental benefit, for example, enhance community resilience, all factors that are very difficult to quantify but need to be considered in the decision-taking process. Economic benefit and the long-term strategy benefit, such a contribution to sustainable development. Those are all benefits that have to be considered as well, but like I told you, this chapter needs to be better proposed. Whatever you decide, you need to have several alternatives for the decision makers, and this process to choose the alternatives is really important, maybe even more than the selection of the mitigation strategies. Once you have decided which mitigation measure you want to implement, then it starts the last step, step 5, the implementation. It might be soft, it might be heavy, but anyway, whatever you do, community need to be engaged. The need assessment has to be done. Feasibility study has to be done in depth, precision, especially when it comes to drainage. A feasibility study in detail must be done. Design and planning, procurement, construction, quality control, community training and handover, post-implementation monitoring, and evaluation and feedback. This is the usual process when you do such a program. And this is actually all what I wanted to tell you. You have realized I have focused my intervention on the flood hazard mapping and the tools. The most difficult is to develop a flood hazard map. Aim is to do for each step, at least up to step 4, a nice, easy to follow tutorial. Let's see if we manage to do that. This depends on many factors. Now I would be more than happy to answer the question. Just keep in mind that the QuantumGIS plugin is still a beta version. It's not totally sound, totally strong. We are still working on that. Hopefully soon we will have the final version. Now I see a question. Please go ahead.
Thank you very much, Andre and Nadine, for the wonderful presentation. And I mean, this comes at a time when we are struggling with floods and in Sudan, and probably I think it's one of the most important tools that we can make use. I just wanted to find out from you, considering the scale and resolution of the data that we have, what is the minimum recommended size for the study?
I do not.
Is there like a minimum?
I do not think that there is a minimum or a maximum. If you have an area that is flood prone, just go define the area. I mean, if you have 10 square meter, of course not. But as soon as you have a site of, say, 1 square kilometer, then you could already have a result. But keep in mind that you cannot limit your observation on a too small area. You have to make your watershed analysis, understand the water is coming from. Watersheds are usually big, even if your site is only 100 square meter and you have 3 houses. The water that reach or flow to your sites come from far away, so you cannot really limit your observation just on your shelter. Keep all the watershed, all the together, and analyze all together. I don't know if you are happy with my answer.
Yes, sure. Thanks.
Please, Marta.
Thank you so much for the wonderful presentation. It really opens like a world for me. My question is really for Adriana, because I think many people, they don't have the capacity, the skills to reach up to such a technical level. So if there is an opportunity, especially for the local organization, to participate and to receive like a training at a previous stage, in order to enable people at least to use GIS and then to have a base for then access these resources and the possibility to use through the tutorials and to also to work on this. But I really think that we need in Sudan training like also at the earlier stage. Thanks.
Thank you, Marta. Well, it was a good question because we need to planify this. I don't know if Andrea, I revert the question to you.
Look, one thing I can answer this. One thing is for sure that everything is free and open source, so everyone can have access. It's just matter to start and to invest time. Tutorials, let's say in mapping, in GIS, are there already. You go to YouTube and you find a huge quantity of tutorials and a crash course for GIS or quantum. You have everything. What you don't might have is the time to study. And but this is not Adriano or me that can give, but the tutorial are theirs, and we are going to prepare a dedicated focus tutorial linked to this presentation for GIS crash course. And if budget allows, we are going also to develop step by step all the hazard mapping. But anyway, anyone can start to learn GIS now because information is there. You go to YouTube and you find in many languages.
Hi, thank you so much, Andrea, for this presentation, and Nadine, thank you so much also for the contribution from the flood tool. I want to just reflect a bit as a person who is who has experience in this area. I know it can be very intimidating, and you don't necessarily need to. I know, like, especially you're working in an emergency, you don't have that time to invest in learning. I think this was an opportunity to share what's possible, what's out there, and to have more ideas of what's the exact support you need. So I think before going into this general concept of flood modeling and flood mitigation, because they're massive and there is a lot to cover, you also need to take some time to reflect on what is actually your need. What are you working on? What's your need? Do you need a basic hazard map to inform planning? Or do you need a mitigation strategy for your work or for a new project to ensure that it is flood prone? So reflecting a bit on this can help you identify the need. We provide support currently to UNHCR operations. This is work, it's important to note, this is work that is done under the Geneva Technical Hub, which is an initiative funded by SDC, and that will be expanding from next year. Now it is only covering UNHCR, but from next year is hoping to expand more partners. And so there are opportunities there. For now, what Andrea shared and what Nadine shared are open source tools. As Andrea mentioned, it's all open source, but all still needs learning. I advise getting in touch, also getting support in-house from your colleagues who are doing information management or who are doing more specific, have more specific technical background on this to support you. Moreover, this doesn't have to be repeated for each and every one, you know. This can be done for a certain area, a bigger area. So I think this is also the cluster's role of bringing everyone together, using expertise from the different cluster partners to together work on a hazard map and then maybe putting together a mitigation strategy, so it can be led by the cluster with expertise from the different partners. Because, yeah, I'm sure Andrea would agree, it's not like everyone has to do it on their own. And then, yeah, you can join forces. Yeah, if there's anything more specific, of course, we would be happy to support further.